Hello and welcome to the lesson on scalar equation of a line. Scalar equation of a line. So we've been working on different equations. We've done the vector, we've done parametric, we've done symmetric. The fourth equation of a line is the scalar equation, and what's the goal today? I can explain how the standard equation was developed, and I can just demonstrate my understanding by taking given information and developing an equation in standard form. So basically, I can tell where it came from or explain where it came from, and I can take that information that I'm given and come up with an equation. So knowledge and understanding straight up, can I follow a process and apply it? So grade 9, you've already seen the standard equation. It's not new. It's our ax plus by plus c equals 0. You used it extensively in the grade 10 course when you did elimination. Standard form was the preferred form. And in grade 12, we move it and we start calling it the scalar equation. We start calling it the scalar equation, or some books refer to it as the Cartesian equation, some of the older books. But we do call it the scalar equation. I'll explain why as we go through. So, just as a reminder too, the dot product, and this is something I didn't talk about quite as much, dot product, in some of the older textbooks, it's also called the scalar product. And the reason it's a scalar product is because when you take the dot product of two vectors, the result is a number, or in our case, we call those scalars. So that's why it's called the scalar product. So we talked about direction vectors, and hopefully in the homework you were able to find a direction vector, find perpendicular vectors, and so on and so forth. The direction vector that's perpendicular, instead of calling it the perpendicular vector, we now call it, or also know it as the normal vector. All right, so perpendicular is the equivalent of what we call normal. Normal means perpendicular. So developing the scalar equation. Developing the scalar equation. So similar to what we did yesterday, I'm going to create a Cartesian plane, and I'm going to show where it came from. So if you give yourself a quick sketch here, it doesn't have to be overly accurate for our purposes, just so you have a bit of a diagram to follow along. Develop the scalar equation passing through the point 4, -1. So right there, so there's my P naught. And with a normal vector, and it should have an arrow above it, so n, okay, just as a side note, n means normal, for a normal vector. Okay, 3, 5. So that means it's a vector with its tail at the origin, and 1, 2, 3, 1, 2, 3, 4, 5. So that means our normal vector has to be perpendicular to a line passing through the point P naught. So we're looking for a line approximately goes like that. So here's the actual line, and there's all our information. So I have to fix up and actually put P naught on the line, make it look a little bit more official. So there we go. So how do we come up with that equation? So, similar to what we did yesterday, I'm going to pick any point on the line. I'm going to call it point P, and its coordinate is xy. And because we are dealing with the normal here, I know a couple of things. I know that if I create a vector called P naught P, okay, so P naught P would be the vector between P naught and P, and I do the dot product with the normal, I know the result will be 0. And that's because the two vectors are perpendicular. So down below, I'm just going to calculate P naught P, that vector. And remember, it's point P minus P naught. So xy minus the point 4, -1. The result will be a vector, x minus 4, y plus 1, and it's an algebraic expression, which is fine. So coming back here, the vector P naught P is x minus 4, y plus 1, dot with the normal. The normal is 3, 5. That's equal to 0. How do you do the dot product when there's algebraic terms in? Same way you would have done multiplication before. We're just using our distributive law. Okay, so x minus 4, the x terms get multiplied together, and the y terms get multiplied together. So we end up with 3 multiplying x minus 4 plus the 5 multiplying y plus 1 equals 0. Cleaning this up, getting rid of the brackets, collecting like terms. So going back to grade 9, 3x minus 12 plus 5y plus 5 equals 0. 3x plus 5y minus 7 equals 0. So there's our final answer. So there's standard form. Now I want to talk about a couple of things that come from standard form. Does anything stand out for you? And hopefully it does. If you look at the coefficients of your x and y, what do you notice? We have a positive 3 and a positive 5. Where have we seen that before? Hey, our normal was 3, 5. Is that a coincidence? Because sometimes math teacher will say, well, actually, that's just the way it worked out. No, absolutely not. In this case, it is in that form where if our normal vector is, what notation? Let's go with n1, comma, n2. Then we will have n1x plus n2y plus some constant equals 0. And that happens or occurs every time. Okay, so it wasn't coincidence. Okay, if you look back at the math, you'll see why it happens, and it comes from the fact that we did this step right here. Okay, so there we go. So to find the standard equation, it's just another process for us in finding a new equation. So there's your fourth equation. So here's your summary. If you look on your next slide, the scalar equation can be found using two forms. So you can do exactly what I just did, and I have some people that do this all the time, or I have some people that do the second process. So it's an either or. You don't have to use both. You don't have to know how to use both, and I'll demonstrate each in the next example here, and you make the decision as to which way you prefer. All right. So here's the example. Find the scalar equation passing through that point, normal to that. So if I do, I'll call it method 1, and you can copy down, or you can watch both and copy down the one that you like best. So P naught P, that's just going to be x minus 6, y minus 2. So that comes from, I take x and y and I subtract my xy coordinate there, dot it with the normal, 2, 5 equals 0. And it's the exact same, I'm doing the exact same process as I did to prove the equation on a previous slide there. So I'll just quickly run through this. 2x minus 12 plus 5y minus 10 equals 0. 2x plus 5y minus 22 equals 0. So there is your final answer. Okay. All right. Method 2 then. Method 2 is starting with the knowledge that you know n1x plus n2y plus c equals 0. So what that means is that 2x plus 5y plus c equals 0. So now with this question, you have to determine the value of your constant. So for 0.62, we substitute in the value. 5 times 2 plus c equals 0. And now we're just solving for c. So 12 plus 10 plus c equals 0. C then equals negative 22. So therefore 2x plus 5y minus 22 equals 0. So both get you the exact same answer. That is the form I need to see. So if you're going to use method 1, those are the steps I need to see in order to get full marks for level 4. Same thing with number 2. These are the exact steps. You can't just skip a bunch of steps because you can, because I'm marking form and process at this point, remember. So you pick the method that you feel most comfortable, you think is best for yourself, and run with it. And like I said, to me as a teacher, it doesn't matter which process you're using. Both will get you through any vector course you come across. All right, so the next example, find a normal vector for the following lines. So really nothing complicated here. What you realize is this is in standard form already. So my normal vector comes from the coefficients on the x and y, so 3 and 2. So that's done. B part. Here's my direction vector, -3, 1. We want the normal vector to both lines. Normal vector is the perpendicular vector to the direction vector with 2D vectors. It's the same as slope. We took the reciprocal and made it negative. Here you take the reciprocal and make one negative, or made the -3 positive, wouldn't matter, and there you go. So there are your two quick and simple answers. So it's just reiterating. You did this yesterday in some of the homework when you're finding perpendicular vectors. Just remember that perpendicular, and this is it's a language shift, perpendicular is equal to normal. All right, so we're just moving you into I always tease you about it's a grown-up vocabulary, but really we're moving you into a more senior vocab when we're dealing with that. So just looking at it, I have 3 more examples to run through, and I'll finish that up in the next video.